Hello everyone. In this video I'm going to show you how to do a parameter sweep inside the analysis of meta-component behavior in the PlanOpSim software. In the last video we created a simple analysis of the spot size of the projected by our meta lens. In this video we're going to take a look at what happens when the incident conditions are slightly different from what we set in our design targets, and we'll see that the spot is modified, for instance, by having a different wavelength of incidence. What you see right now is the analysis that we did previously, so the projected spot and near field wavefront for the target wavelength of 940 nanometers. Now, if we want to do a little parameter variation on that, we can do so by going into the sweep variables table, which is now empty, and add there a variable. For example, the wavelength, and we'll do a variation of that from 900 to 1000 nanometer. I'm writing 1001 because the last point is excluded from the sweep, so when we do 1001 we will still have the 1000 point inside. We can save that. Now we need to assign that wavelength, that parameter, to the wavelength variable here. So as before, I will just write equal wavelength. In this case, I can select it from the drop down. There we go. And I need to make sure, since I wrote 900 to 1000, that this unit is nanometer, not micrometer. This will now repeat the analysis that we did for a single wavelength for all of these parameters in the next analysis. I could overwrite the one I'm currently using called spot by using update analysis, but since I want to keep that, I'll call this one a wavelength sweep. And then to trigger the calculation, all we have to do is click New Analysis, Confirm. This will bring up the progress bar. Once the calculation's done, we can inspect the result. Voila, our analysis has completed. We see that now a slider bar has popped up here with our parameter wavelength starting at 900 nanometer. And here on the right we have the same plots as before, the near field wavefront for that wavelength and the far field wavefront projected at the location we set, which is still the focal plane here at 75 micrometers. And we see, if we compare, we can slide through all the wavelengths here. So let's first go to 940, our design wavelength. Here we have a small and confined focal spot. If we move away from the designed focal point, we see that the spot starts to gradually at first, but then as we go further and further out of the design target, more and more starts to widen, both for shorter wavelengths as for longer wavelength. If you want to export this data, you can do that by the export raw data button, which will export this configuration and download it for all of the plots. So this will contain the plots you see here for all wavelengths. We can even expand the analysis a bit further. Let's say, for example, we're not just interested in spectral behavior, but also in the angle of incidence or field of view. So I could add here a little, an additional sweep variable called angle. And let's say I will vary this from 0 to 15 degrees. Well, let's say 15 degrees in steps of 5. So we're just having two angles. Now we have a dual sweep. We will change the wavelength and the angle when we assign the angle here as well. So angle, and let's give this analysis a new name as well. So we'll call this wavelength plus angle sweep, and once again click New Analysis and let that run. Okay, there we go. And now that the calculation has finished, we see that there's an additional slider bar now, where before we only had wavelength. Now there's also the angle, which we can slide So we actually have a grid of simulations that was done here for different wavelengths and angles. So for example, if we go to the center wavelength of 940 nanometer, we can look at its behavior at normal incidence or 5-degree incidence, and we see that the spots location has shifted from exactly in the center to a slightly off center. Here we were just using a small map size to see in detail what the spot looks like, but we could do this for larger simulations as well. If we ever want to take a look at a previous analysis that we did, because we click new analysis every time, all older analysis are stored in here under analysis job. So we could go back, for example, to the wavelength sweep that we did just before and have once again only the wavelength slider in. This is how we can do a swept parameter analysis on a meta lens inside the PlanOpSim software. Thanks for watching.